Hey everyone, welcome back. Today, we're going to dive into a couple of really powerful C++ features, operator overloading and type conversion. Now I know, they sound kind of intimidating, right? But trust me, they're all about one super simple, super cool idea. Making your own custom data types, your classes, act just as naturally as the built-in ones, like integers and floats. By the time we're done, you'll see how this can make your code way more intuitive and just cleaner. So let's jump right in.
All right, so let's set the stage here. Take a look at the image on the left. C++ has absolutely no problem with this, right? It sees an integer, a float, and a plus sign, and it knows exactly what to do. Easy peasy. But then, look at the code on the right. We go and create our own custom class, let's call it class A, and we try to add two of our A objects together. And what happens? Bam! The compiler just throws its hands up in the air. It's totally confused. It has no clue what the plus sign is supposed to do with our brand new data type.
And that, right there, is the big question for today. How do we fix this? How do we basically hand C++ an instruction manual for our classes? How can we teach it to use an operator we already know and love, like the plus sign, with the custom things we've built?
Okay, so here's our game plan. First, we'll talk about why operators even need our help. Then we'll get into the fun part, giving them new powers for both unary and binary operators. From there, we'll look at converting between data types, and we'll wrap up with the really important rules of the road.
All right, section 1, why operators need help. So why do we even have to do any of this? Well, the short answer is that operators like plus, minus, and multiply, they come pre-programmed, but only for the built-in types. Your int, float, double, etc. When you create your own class, it's a completely blank slate. The language has no built-in assumptions about what you want to do.
And this is exactly where operator overloading comes to the rescue. The key thing to get here, and this is really important, is that we are not changing what the plus sign does to integers. We're not breaking C++. All we're doing is giving it an extra job, an additional meaning. It's like giving your calculator a new button. It can still add numbers, but now it can also do this new, special thing for our class. It's a classic example of polymorphism, where one thing can take on many forms.
So, how do we pull off this magic trick? It all comes down to a special kind of function called, you guessed it, an operator function. This is literally the blueprint we write to teach an old operator a new trick.
And honestly, the syntax is way simpler than you might think. Just look at the blueprint here. It looks almost like a regular function, right? You've got your return type, but then here's the cool part. You use the keyword operator, and right after it, you put the symbol you want to overload, like plus or minus. That whole thing, like operator plus, becomes the function's name. It's that simple.
Now you've got two main ways to write these operator functions, either as a member function inside the class or as a friend function, which is technically outside the class. And the biggest difference you'll notice is the number of arguments they need. Think about it. If you're overloading plus as a member function, the object on the left of the plus sign is the one calling the function. It already knows who it is. It has access to itself through the this pointer, so it only needs you to pass it the object on the right. But a friend function, it's like an outside consultant. It doesn't belong to the class, so you have to hand it both objects involved in the operation.
Okay, theory's great, but let's see some code. We'll start with the easy stuff, unary operators. These are the ones that only work on one thing at a time. The perfect example is the unary minus, the one that just flips a number sign from positive to negative.
Check out this example. Inside our code class, you can see the definition, void operator minus minus. And just like we talked about, because it's a member function and it's unary, it takes 0 arguments. Perfect. All the function does is go into the class, grab the member variable a, and flips its sign. And look at the output! It works! In our main function, we create an object, object1, give it a value of 6, then we just write minus object1, it looks so natural, and behind the scenes, our overloaded function gets called. The value flips to -6, beautiful!
Okay, so now let's try the exact same thing, but this time using a friend function. See the difference? Inside the class, the declaration changes to friend void operator minus code end. And then, when we define it outside, look, it now takes one argument, a reference to our code object. The end result is exactly the same, but the setup is just a little different.
All right, unary operators? Check. Now let's move on to the really common stuff, binary operators. These are the workhorses, right? Your addition, subtraction, multiplication, the ones that need two things to work on.
And the classic textbook example for this, for good reason, is a complex number class. Remember those from math class? They have a real part and an imaginary part. So if you had two of them, C++ would have no built-in logic for adding them. It wouldn't know to add the real parts together and then add the imaginary parts together. It's up to us to spell that out.
And this is the payoff. Once we've defined operator plus and operator minus for our complex class, our code becomes so clean and readable. It looks just like regular math. The sum is calculated correctly, the subtraction is calculated correctly, our custom type now plays nicely with the standard operators.
Okay, so operator overloading is awesome. But what about situations where there's no operator involved? Like, what if you just want to assign a plain old integer value to an object of your class? This brings us to a closely related topic, type conversion. And yeah, C++ has tools for that too.
You're going to run into three main types of conversions. First, from a basic type to your class type, like turning an int into one of your objects. Second, from your class type back to a basic type. And third, converting from one of your custom classes to another custom class.
I love this slide because it's basically your cheat sheet. It tells you exactly which tool to use for which job. Want to go from a basic type to a class? You use a constructor in the destination class. Want to go the other way, from your class back to a basic type? You use something called a casting operator inside your source class. And for class to class, well, you've got options. You can use either one, depending on where it makes more sense to put the code.
Let's make this concrete with an example. We've got this time class. Now, see that constructor? Time int n? That's our tool for converting a basic type, an integer representing minutes, into a time object. Then, a little further down, you see operator int. That's our casting operator. That's the code that tells C++ how to turn a time object back into a plain old integer.
And here's the output, showing it all in action. The program takes 234 minutes, automatically uses that constructor to create a time object, and correctly figures out that's 3 hours and 54 minutes. Then, it uses the casting operator to convert the object back into an int, giving us the total hours, which is 3. It's totally seamless. The conversions just happen.
Okay, we've covered a ton. Before we wrap up, let's talk about the rules of the game. Operator overloading is, without a doubt, a superpower. But with great power comes great responsibility. And there are some really important limitations you have to know about.
Okay, rule number 1, and this is a biggie. Some operators are completely off limits. You cannot touch them. C++ puts a force field around fundamental operators like the scope resolution operator, the dot operator for member access, and sizeof. I mean, can you imagine the chaos if you could change what those do? It would just break the entire language.
And then there's another set of rules. For certain operators, specifically the assignment operator, the function call parentheses, the square brackets for arrays, and the arrow operator, you can only overload them as member functions. No friend functions allowed for these guys. The compiler enforces this for some very good reasons, mainly to avoid some really confusing and tricky problems.
So, that leaves us with a pretty cool final thought to chew on. When you teach the plus operator how to handle your complex numbers, or you teach the minus operator how to work on your own objects, you're making your own creations feel like they were a built-in part of C++ from day one. So think about this. Are you just writing code anymore, or are you actually extending the language itself? It's a pretty powerful idea. Thanks for hanging out with me for this explainer, and I'll catch you on the next one.